Good day, everyone, and welcome to Learn with Mike. So, for today's topic is the continuation of our topic about projectile motion. So, for today's topic, it's about projectile motion 2 or projectile at an angle. So, let's start. So, it is also called as type 2 projectiles or projectile at an angle. So, projectile 1 has no angle, but projectile 2 has an angle. So, let's study this diagram. So, as you can see, the kick or the football was kicked and it forms a projectile motion. So, there is a curved line. Now, as you can see, as you can see in the diagram, type 2 projectiles are thrown from the ground. So, from the ground at an angle of less than 90 degrees but more than 0 degree. Okay, so to understand, let's have this diagram. Suppose we have a ball. So this ball will go to a projectile motion. So suppose one will kick the ball, so it will go to this direction. It will form a projectile motion like this. And at this point, at the last point of the ball, it is, or we can consider that it is the maximum height of the ball. Okay? So, the ball reaches its maximum height at this point. Now, the tendency of the ball, if it's, for example, it reaches the maximum height, is to stop. So, we can say that the final velocity or velocity Vy of the ball at this position is 0. Then, after it stops, the tendency of the ball is to go down. So, to go down, going to the ground. So, to the ground, that is the final position of the ball. And the velocity of the ball at its final position is equal to 0. Now, in this diagram, we can draw some lines. So, from the highest point of the ball to the ground, so this line, this is now what we call the maximum height or the dy. So, later we will compute the maximum height or the dy. And then, from the starting point to the end point of the ball, that is the dx or the range. So later again we will compute that. Now, take note that there is always time, okay, in projectile motion. So time going up according to the condition. So we have time where the ball goes up, and also we have the time where the ball goes down from its highest position. And according to the condition of projectile motion, time going up is equal to time going down. So, if the time going up is 2 seconds, time going down is also equal to 2 seconds. And the total time, okay, to compute for the total time where the ball is in the air, is just simply we need to add time going up and then plus time going down. Or just simply multiply by 2. And then, we can also draw some lines to represent. So this line, it's like the hypotenuse in mathematics. And also we have this line. So take note that the hypotenuse or the longest line, we consider it, or before that, because we have a triangle, so there is an angle. Okay? And then going back to the hypotenuse, that is our Vi or the initial velocity. And then, because it is a triangle, and if we have a hypotenuse, we also have bases. So, here is the Vix, or the initial velocity at x-axis, and then we have Viy, initial velocity at y-axis. So, Vi, Vix, and Viy are different from each other. So, later you will know what is the reason why we have Vi, Vix, and Viy. So let's have an example. Or before the example, let's have the formulas that we need to use. So for Vix, it is equal to Vi cosine theta. Viy is equal to Vi sine theta. Dx is equal to Vix times the time. Dy, we have new formula. Open close parenthesis, Vy squared minus Viy squared over 2g. Then for time, so time going up or going down, they actually have the same formula, 2 dy over g. The difference is, if we compute for the time going up, g is negative because the normal direction of gravity is downward. If we counter it, so time going up, it is negative. And for time going down, g is positive, or 9.8 is positive. And then for the total time, like what I've said, we just simply need to add 2, or time going up, and then time going down. Their values are just the same. Okay, so you can just multiply it by 2. Where? So these are the meaning of each quantity. Vix is the initial horizontal velocity. Viy is the initial vertical velocity. Vi is the initial velocity at an angle. So Vix is the base 1 in the diagram that we had. So the triangle. Viy is the y-axis and Vi is the hypotenuse. Vy is the final velocity. Commonly, Vy is equal to 0 because it is the ball or the object is at the highest position. The tendency of the object is to stop. So in all the problem solving, or in most of the problem solving, Vy is equal to 0. Dx is horizontal distance or the range. Dy is the vertical distance or maximum height. T, big letter T or small letter t, is the time. So it can be time going up, time going down, or time total. But commonly, we compute for the time total. And g is the acceleration due to gravity, which is 9.8 meters per second squared. So let's have an example problem. A golf ball was hit and projected at an angle of 60 degrees with the horizontal. If the initial velocity of the ball was 50 meters per second, neglect air friction, then calculate the following. Always, in projectile motion 2, in most of the books and references, we compute for the 3 quantities. We have the maximum height the ball reached, which is the dy, time of flight t, or this is the time total, and the horizontal distance the ball traveled, or dx. So let's start the computation. So here, let us write the given. We have Vi is equal to 50 meters per second. The angle is 60 degrees. And g, always, because this is projectile motion, this is 9.8 meters per second squared. And the unknown is the dy, the time total, and the dx. So dy is the vertical, and then dx is the horizontal distance. For the solution, let us first solve the Vix and Viy based on the value of Vi. So the formula for Vix is equal to Vi cosine theta. So substituting the values, Vi is 50 meters per second, multiply by cosine, so the angle is 60 degrees. So here you can use scientific calculator. So 50 times cosine 60 degrees, so Vix is equal to 25 meters per second. And for Viy, Vi times sine theta. Substituting the values, so 50 meters per second times sine 60, so Viy is equal to 43.30 meters per second. Now that we have the Vix and Viy, let's solve for the maximum height, or the dy. So the formula, so including the solution, the formula is dy is equal to, open close parenthesis, Vy squared minus Viy squared over 2g. Like what I've said, most of the time, Vy is equal to 0. So it is equal to 0 meter per second square minus, so the value of Viy that we computed is 43.30. So we substitute it, then square over 2 times negative 9.8 meter per second squared. So that is negative because we assume that the dy we use to have that the object is going upward, and if the object is going upward, the g is negative. Okay? And also I use negative so that in the final answer it is positive, because in the numerator it is negative, so the denominator must be negative also. Take note, there is no negative distance. So now, the first thing to do is to get the square of 43.30, and that is 1,874.89 meters squared over second squared. So 2 times negative 9.8, that is negative 19.6 meter per second squared. Then equal sign, 0 minus 1,874.89 meters squared over second squared is still the same. So negative 1,874.89 meters squared over second squared over negative 19.6 meter per second squared. So from this, cancel some units. The remaining unit must be meter because we are computing the dy. So negative 1,874.89 divided by negative 19.6 is equal to positive 95.66 meters. So that is our dy. Now, let's solve for the time of flight or the t total. So from here, we can use the formula t down. Why t down? Because in t down, the gravity is positive and we know that we cannot get the square root of a negative number. So if we use t up formula, but it is just the same with t down. So the formula for t down is square root of t dy over g. So dy, which we computed earlier, is 95.66 times 2 over 9.8 meter per second squared. So 2 times 95.66 is 191.32 over 9.8 meter per second squared. So divide. So if we divide, the answer is 19.52 seconds square. Then get the square root or cancel. If we get the square root of s squared, cancel square. Square root of 19.52 is 4.42 seconds. Since time going down is equal to time going up, so time going up is also equal to 4.42 seconds. And to compute for t total, we just need to add the 2. So 4.42 seconds plus 4.42 seconds is equal to 8.84 seconds. So that is the time total. And now for the last, let's compute for the horizontal distance or dx. So the formula is simply VIX times time. So as you can see, in the formula, we were going to use VIX. So that is the reason why we compute VIX and VIY. That has cosine and sine theta. So VIX is 25 and then the time that we computed is 8.84 seconds. Cancel second. 25 times 8.84 is equal to 221 meters. So the solution is very long. So you need to practice this topic. Actually, this topic is not so easy. Next, sample problem number 2. A long jumper leaves the ground with an initial velocity of 10 meters per second at an angle of 27 degrees above the horizontal. So find the dy, time, and the dx. Actually, it has the same solution, but the given are different, but the solution is just the same. So given, we have VI is equal to 10 meters per second, angle is 27 degree, G is 9.8 meters per second squared. Then the unknown, dy, t total, and the dx. For the solution, so again, let's solve for VIX and VIY based on the VI, which is 10 meters per second. So VIX is equal to VI cosine theta. Substitute 10 meters per second times cosine 27 is equal to 8.91 meters per second. For VIY, VI times sine theta. So 10 meters per second times sine 27. So VIY is equal to 4.54 meters per second. Now let's compute for the dy. Formula, same formula. dy is equal to open close parenthesis vy squared minus viy squared over 2g. Since vy is always equal to 0, then it's 0 meter per second square minus, so viy is 4.54 square over 2 times negative 9.8 meters per second squared. So let us get the square of 4.54, that is 20.6116 meters square over second squared. Then the product of 2 times negative 9.8 is negative 19.6. Then 0 minus negative 20.6116 is still the same. Negative 20.6116 meters squared over second squared divided by negative 19.6 meter per second squared is equal to, or cancelling some of the units, so dy is equal to 1.05 meter. Then next, for the time, t total, same solution. So the formula is 2 dy over g. Substituting the value of dy, that is 1.05 meter, multiplied by 2, that is 2.1 meters. Then divided by 9.8, cancel m. So 2.1 divided by 9.8 is equal to 0.21 seconds square. Cancel square. Then square root of 0.21 is 0.46. 0.46 second. Since T down is equal to T up, then T up is equal to 0.46 seconds. To get the time total, just add 0.46 seconds plus 0.46. So the time total is 0.92 second. And then for dx, or horizontal distance, so Vix times time, Vix is equal to 8.91 meters per second times the computed time, which is 0.92 seconds. Cancel second. Then the product is 8.20 meters. And for my last example, a football is kicked with a velocity of 20 meters per second at an angle of 37 degrees with the horizontal. Determine the dy, time, and the dx. Almost the same. So given, we have Vi is equal to 20 meters per second, angle is 37 degrees, and G is 9.8 meters per second squared. The unknown, dy, t total, and dx. Solution, once again, we solve for Vix and Viy based on the Vi, which is 20. So Vix, substituting the values, 20 times cosine 37 is equal to 15.97 meters per second. Viy, we use sine. So 20 times sine 37, that is 12.04 meters per second. Now let's solve for the height, or dy. Same formula. So Vy squared minus Viy squared over 2g. And again, Vy is always 0. Take note of that. Take note of that in this type of problem solving. Minus, so Viy is 12.04 square over 2 times negative 9.8. So the square of 12.04 is negative 144.9616 over negative 19.6 meter per second squared. Okay? So, next, negative 144.9616 divided by negative 19.6. Cancel the unit. Okay, the remaining unit is meter. Okay, so the dy is 7.40 meters. And for the time, so still the same, square root of 2 dy over g. Dy is 7.40 meters. 2 times 7.40 is 14.8 meters divided by 9.8 meter per second squared. So cancel m. So the division is 1.51 seconds square. Square root of that, cancel square, is 1.23 seconds. Since time going down is equal to time going up, so time going up is also equal to 1.23 seconds. So to compute for the time total, just simply add 1.23 plus 1.23, or 1.23 times 2. Then we have 2.46 seconds. And last, for the dx formula, Vix times time. So Vix 15.97 times 2.46 seconds. Cancel s. Then the product is 39.29 meters. So that's all for now. Thank you for watching, and I hope you learn. So I suggest that you repeat this video maybe 5 times to 10 times so you can get the lesson. Okay? So thank you.